Okay, so I'm going to go through this, the last example that was in your notes that we didn't get a chance to finish the other day, in hopes that that will help you complete your homework assignment on 10.3a polar. So it says to find the points of horizontal and vertical tangency to the graph of r equals 2 minus 2 cosine theta. Well, hopefully you recall from our discussion today that this would be a cardioid. It would be a cardioid with, it would be symmetric about the x-axis because of the cosine. Its farthest distance from the pole would be 4 units because of the 2 plus 2. Its closest distance to the pole would be 0 because the twos net one another out along the x-axis, and then this 2 would dictate how far you move in the y direction. So if you want a picture to think about this, all points of vertical and horizontal tangency, you might think about this one. So I just put that graph in my calculator. And to me, it looks like I have vertical tangency here, 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 and then I have horizontal tangency here and here. And that's basically what I've been asked for. And then something in here, but a little hard to tell what's happening. So that's a visual of what we've been asked to find. So now I need to think about the algebra and calculus involved there. I know that if I'm dealing with horizontal tangency, that I'm looking for where dy d theta equals 0 and dx d theta does not equal 0. And for vertical tangents, I would be looking for where dx d theta equals 0, dy d theta doesn't equal 0. Because remember that 0 over 0 would give me something indeterminate there. So, and remember we broke that into pieces because dy dx for purposes of polar is defined to be dy d theta over dx d theta. So where the numerator is equal to 0, I get 0 over a number, I would have a horizontal tangent, but if I have a number over 0, that's where I would have a vertical tangent because that's undefined. So probably the next thing I need to do is talk about this, how to come up with this formula. Remember that, I'll go back over here. Remember that y is defined to be r sine theta, and x is defined to be r cosine theta, because it's these two equations that we're going to use to help us come up with my derivative. So dy d theta, I'm going to have to use the product rule here. So I'm going to have the first times the derivative of the second. R is the first, the derivative of sine, which is cosine, is the second. Plus the second, which is sine theta, times the derivative of the first, which is r. And remember, this is with respect to theta, so I have to attach a dr d theta. It's 1 dr d theta. So that's your dy d theta portion. And then to get dx d theta, I'm going to go to the equation that says that x is equal to r cosine theta, and I'm going to take the derivative of it with respect to theta using the product rule. So the first times the derivative of the second, that's going to be negative sine theta, plus the second, which is cosine, times the derivative of the first, which will be that 1 dr d theta again. And now I'm going to have to substitute into this particular formula. I know r, it was given to me, r is 2 minus 2 cosine theta. And I also see that I'm going to need a dr d theta, which I can figure out right here. Dr d theta is going to end up being derivative 2, 0. And this will be negative 2 derivative of cosine theta is negative sine theta, so it will end up being positive 2 sine theta. Okay, so again, so dy d theta is r cosine theta. The r is 2 minus 2 cosine theta times cosine theta plus sine theta times dr d theta, which I found right here to be 2 sine theta. And it is this quantity that I want to be equal to 0. So now I'm going to have to do some algebra. I'm going to distribute the cosine to both pieces of this. I'm going to have 2 cosine theta minus 2 cosine squared theta plus 2 sine squared theta is equal to 0. I've got an equation here, but I've got sine and cosine in it, and that isn't going to work if I don't have a calculator. So I'm going to have to replace sine squared theta with 1 minus cosine squared theta, which is the Pythagorean identity, right? Cosine squared theta plus sine squared theta is equal to 1. So I can solve it for sine squared theta and replace that, and now my equation will all be in terms of cosine. So I'm going to have 2 cosine theta minus 2 cosine squared theta plus 2 times 1 minus cosine squared theta, still equal to 0. I'll distribute the 2 cosine theta minus 2 cosine squared theta plus 2 minus 2 cosine squared theta is equal to 0. Now I've got some like terms I can combine, and now it looks a whole lot like a quadratic equation. I have a squared term and not squared term and a constant. So I'll combine these. I'm going to have negative 4 cosine squared theta plus 2 cosine theta plus 2 is equal to 0. I can factor out a negative 2. That leaves me 2 cosine squared theta minus cosine theta minus 1 is equal to 0. Divide both sides by the negative 2. And there's a quadratic that I can factor. And this will factor into 2 cosine theta plus 1 cosine theta minus 1 is equal to 0. So that means zero product property, right? Either this one has to be 0 or this piece has to be 0. So 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0. So cosine theta equals negative 1/2. Oh, and because I'm about to solve this, I did add this to the problem that theta needed to be between 0 and 2 pi. So now I'm looking for where cosine theta is negative 1/2, and on that interval 0 to 2 pi, that would be at theta is equal to 2 pi thirds and 4 pi thirds. Or I'm looking for where cosine theta is equal to 1, and that would occur at theta equals 0 and 2 pi. Okay, so these are all the possibilities, all the values of theta that would make dy d theta equal to 0. So now I'm going to have to do the same thing for the dx d theta, so that I can look at potential vertical tangents, right, where dy d theta equals 0 are potential horizontal tangents. So let's go back up here to dx d theta. We will replace these values that we have in the denominator. So it's negative r. So I'm going to go ahead and distribute the negative sign to the r up here. So that's going to make negative 2 plus 2 cosine theta all of that's times sine theta, plus cosine theta times dr d theta, which I found to be 2 sine theta, and that's equal to 0. I'll distribute here. And I have negative 2 sine theta plus 2 cosine theta sine theta plus 2 cosine theta sine theta. And again, I want where that's equal to 0. Okay, I'm going to combine these two. Those are like terms. I'm going to have negative 2 sine theta plus 4 cosine theta sine theta is equal to 0. And I can now factor out a negative 2 sine theta, and I'll create a multiplication problem, which is what I need to use the zero product property. So I'll factor out my negative 2 sine theta, and that leaves me with 1 minus 2 cosine theta equals 0, which means that either negative 2 sine theta equals 0 or 1 minus 2 cosine theta equals 0. So I'm looking for where sine theta equals 0 or where cosine theta would equal positive 1/2. Move the 1 to the other side and divide by the negative 2. So between 0 and 2 pi, sine theta is 0 at 0, pi, and 2 pi. And cosine is 1/2 at pi thirds in the first quadrant and 5 pi thirds in the fourth quadrant. Okay, so what I immediately see is I have 0 and 2 pi, and 0 and 2 pi. And remember that for horizontal tangent, the denominator can't be 0, and for vertical tangent, if the denominator is 0, the numerator can't. So since 0 and 2 pi are values that they share, we're going to have to cross those out. They won't be included. So my values of theta, where I have a horizontal tangent, are at 2 pi thirds, 4 pi thirds. And I would have a vertical tangent at pi, pi thirds, and 5 pi thirds. And then clearly it asks you for the points, so I guess technically we would need to go back and figure out what r is. I don't know if I'll do that for all of them, but r would be equal to, in this particular case, 2 minus 2 cosine 2 pi thirds. So that's 2 minus 2 cosine at 2 pi thirds would be negative 1/2. So that's 2 plus 1 is 3. And that's how you would find all of the corresponding r values. So let's go back and look at my picture that I had here. And all of these things seem to make some sense, right? So at 3 2 pi thirds, I should have a horizontal tangent. So if I go to approximately 2 pi thirds, here's quadrant 1, here's quadrant 2, so somewhere in here, 2 pi thirds, and I go out 3 units, I'm betting that takes me to that point right there, which is a horizontal tangent. Similarly, let's see, 1, 2, 3, 4. Let's see what happens when we plug in pi over here. R would be equal to 2 minus 2 cosine pi. So that's 2 minus 2 times negative 1, which indeed gives me 4. And if you think about that, that means that at pi comma 4, it says I should have a vertical tangent. Well, I go over to pi and I go out 4 units, and I do indeed have a vertical tangent. So I won't finish that, but that's how this would work. My points would be 2 pi thirds 3. Oh, sorry, r theta, my bad. 3 2 pi thirds. I'd find the corresponding r for 4 pi thirds. Over here, I just found 4 pi, and then I would do the same for pi thirds and 5 pi thirds, and you should be able to go back to the graph and make sense of all of those things. So that's the way to approach a problem like this one, and clearly there's a lot going on there. So try those last problems in your homework, and we'll get started on some area tomorrow.